Hi, today let's look into how to insert in a sorted linked list. Suppose we have this linked list, say 25, 36, 47, 58, 80 and null. So this is sorted ascending order. As you can see, every node's value is less than the next node's value. So to keep the list sorted, the new value must be placed between the two nodes where left is less than or equal to key that is given to us and that is less than or equal to right. So what can be the possible insertion positions? One can be here, 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 or here. So it depends on the value of the key that they give us. So let's look into the first case. So this is insert at the beginning. So let's say we need to insert a new node, say 19. Now in the above linked list, just compare this node value with all the nodes value. So 19 is less than 25. So what happens is we got to insert this node at the beginning. So 19 is less than 25 is less than whatever the next value and so on and null. Okay. So right now this particular 19 node will become the head. So if the key is smaller than the head node, it must become the new head of the list. And next is case 2. So suppose we need to insert the value of the node, say 40, and the linked list is 10, 30, 50, 70 and null. So now we got a traverse. Let's initialize a pointer named current to the first node. So we need to check current dot next dot data. So what will be the current dot next dot data for this? So the next node of this particular node will be 30 and the data of it will be 30. So the node will be 30 and the data will be 30. So we have to compare 40 with 30. So since 40 is greater than 30, we need to move to the next step. So right now current will go here and we repeat this same process. But here 50 is greater than 40. So what we will have to do is we need to move while the next node's value is smaller. The moment it becomes larger, we stop. So now we got to insert 40 in between 30 and 50. So the linked list becomes 10, 30, 40 will be inserted between 30 and 50, 70 and null. So this ensures the key is placed between the two correct values, that is 30 and 40. So this is the condition if we got to insert in between. Now coming to the case 3 where we need to insert at the end. Let's say we have the linked list 15, 25, 35 and null. And the new node that is to be inserted is 50. Okay. So repeat the same process. We have current pointed to the first node and we start the traversal in a similar way like how we did in the case 2. So in this case we check till the current dot next is null. So it means this key will be the largest value. Okay, so we repeat the same process. We go here, we check this one, then we check here, and then this condition will be satisfied when current dot next is null. So in that case the linked list becomes 15, 25, 35. 50 will be inserted between 35 and null. So the condition here is the new node dot next is null and current dot next is new node. So inserting at the end is just inserting after the last node. So the handled cases in this problem is 1 inserting at the beginning, 2 inserting in the middle, 3 inserting at the end, and last is the empty list that we'll look in the coding part. So as you must have identified, we traverse the list at most once, so the time complexity will be big of and the space complexity will be big of 1. So now let's look at the coding logic. Here we are given the head of a sorted linked list and a key, and our goal is to insert the key while keeping the list sorted. We firstly need to create a new node with the given key. Let's now handle the insert at the beginning. If head is none, or head dot data is greater than or equals to key, new node dot next is head, and we return the new node. So if the list is empty or the head value is greater than or equal to the key, the new node must be inserted at the beginning. So we simply point the new node to the current head and return it. What is the next step? We got to initialize the traversal pointer. Current is head. We start by traversing the list using a pointer called current. Now, next step is to find the correct position to insert while traversing. While current dot next is not none and current dot next dot data is less than or equals to key, then we do current equals to current dot next. We move forward as long as node exists and its value is still smaller than the key. We stop exactly at the node after which the key should be inserted. Checking the next node helps us insert without losing the links. Now we perform the actual insertion. New node dot next is current dot next and current dot next is new node. First, the new node points to the current's next node, and then current points to the new node. And this handles both middle insertion and end insertion when current dot next is null. Since the head does not change in middle or end insertion, we return the original head, say return head. Now let's go ahead and run this code. As we can see, the insertions like at beginning, in the middle, at the end, and an empty list are handled. And in case of duplicates, a new node is inserted after existing equal values because traversal stops when current dot next dot data is equal to the key. Also, depending on the requirements, we can control whether duplicates go before or after changing one comparison operator. Thanks for watching.